So we've got our second day of Unit 3, Parallel and Perpendicular Lines, the 3.4 to 3.6 parallel and perpendicular lines, and their slope. So we're going to start with this question here. We're continuing to find slope. Just a reminder, last time we did this, we used that slope box, slope triangle, and we've got a slope formula. So any of those three ways are great ways of doing it. Once again, I personally prefer the slope box or the slope triangle, because I think the slope formula gets a little confusing, but we're actually going to demonstrate all three ways on this question number 5, and then we'll move on to the rest of them, and you can kind of pick and choose your own way, but at least you've seen them all and you can choose what you want. So we are going to start with our slope box. So I'm going to just draw my box here. Remember, we've got the x and the y values, and we just want to put them in our table. So it doesn't matter where we start with. I'll start with t this time. So that coordinate of t is going to be 6, 3. So I can put that in my table, and I can put the 6, 3 into my table right there. Let me try and color code this for you guys too. So 6, 3. And we've got our point S, which we will label as 4, -2. Once again, it's just x, y, so we're just going to put that into our table. And now, remember with slope, the way that we calculate slope here is slope is rise over run, or we can consider that as delta y, and remember delta means the change of y and change of x. So how is y changing? Well, I can take a look at this, and how do I get from 3 to -2? Well, I know I'm going down, so that's going to be subtraction, and I'm going to go down 5 to get that answer. So I know that's going to be a -5 right there. And then I look at my change of x. How is that changing? So how do I get from 6 to 4? Well, once again, I'm decreasing, so that's going to be negative, and I'm decreasing by 2. So it'll be -5 over -2, and I don't want to leave my answer as negative over negative, because I know that a negative divided by a negative is going to be a positive. So therefore, my slope is just going to be 5/2. All right, and that is one great way of getting it. Remember, you can always do the slope triangle, which is pretty much the same thing. We're just going to draw from our S, we're going to go out over here, so we're going to make a right triangle. This is great. We'll get to like distance formula, Pythagorean theorem, all great things there with that slope triangle. But I can see here for the S that I'm going, my run is going to be 2. I go over 2 spaces, and my rise is going to be a +5. I go up 5. So therefore, my rise over my run would be 5/2, which is exactly what we have going on right here. So both of those are very similar to the same form. The table is just putting it in a table form, and the slope triangle is just looking at the graph. But the other way is that slope equation, and once again, like I said, I did want to go over that, just at least give you guys one example of it. So remember, your slope formula is going to be slope is equal to y1 minus y2 all over x1 minus x2. And this is doing the same thing. You can see we're still subtracting the y values, just like we subtracted y values right here. And then we're also subtracting x values just like we did here. So it's all the same process, it's just how you look at it. Personally, the minuses and the y1 and y2 get confusing, but let's do it. So when I want to plug in for this, I've got to plug in my 2 y values. Okay, so I see one of my y values being the 3 right there, and the other value being the -2. So I want to put into my equation 3 minus a -2 over my 2 x values. My x values are 4 and 6. And once again, the order doesn't matter, but it does matter that we keep it consistent. So if 3 was my first number, then that 6 has to be my first number in the bottom of the fraction. So 6 minus 4. And if you feel great with 3 minus a -2, that could get complicated, but that's just a 3 plus a +2, which would be 5, and 6 minus 4 2. So all 3 ways that we did it, we still got our answer of 5 over 2. So whichever way you prefer, do it. I hope you enjoy it. I will be doing slope box more than likely, or slope table more than likely in most of these problems. But do it whichever way you want. Whichever answer you get is great. All right, so we've got that answer there. So now let's look at number 4. We'll just do this one way. I'll just do the slope box. So we got my x, we have our y. Divide the table into quarters. Point, doesn't matter which one goes first, so we'll start out with that one because it's on the left side. So that's going to be a -5. And then I go up 1, so 1 right there. So -5, comma 1. And point A is going to be 0, comma 1. So I'll put my 0 right there and my 1 right there. So once again, we just want to find that change of y. So how is y changing? Well, how do I get from 1 to 1? Well, it's pretty easy. I'm just going to add 0. So my slope is going to be a +0 over. And how do I get from -5 to 0? I want to add 5 to both sides. So I'm going to add 5 there. And when I look at that, a positive over positive is a positive, so I can just get rid of that. But let's also take a look at what is 0 divided by 5. If you type that into your calculator, you forget what that is just going to be 0. So that line has a slope of 0. And hopefully remember that a horizontal line, one that's completely flat, is going to have a slope of 0. I always like to think of it as a skier. If a skier skis this slope right here, how fast are they going to go? Right? They're going to go 0 miles per hour. How far are they going to go? They're going to go 0 miles or 0 feet. So if you ski a slope that is completely horizontal, you're going nowhere. So it's going to be m equals 0. My slope of that is going to be 0. All right, taking a look at the next problem. Number 10, let's make a slope box. Let's look at this first point. We'll do A. So that's going to be 0, comma 7. Put that in our table, 0, comma 7. And then B is going to be 0, comma 3. Once again, let's put that in our table. And let's find that change of y. So how is y changing? How do I get from 7 to 3? Well, I will be subtracting 4. So that's going to be my numerator, go on top. And how do I get from 0 to 0? Well, that is adding 0 once again. So now I'm going to put a +0 on the bottom. And so on the last one, it was a horizontal line. It went sideways. The 0 was in the top of the fraction, and you can take your calculator and you can do 0 divided by anything at 0. This time it's a little bit different. If I type into my calculator -4 divided by 0, we're going to get an error or an undefined slope. So we say that this has no slope. You can use a symbol, which is like the kind of the 0 through the line through it, or you can say it's undefined. Any of those are great ways of saying it. And if we want to go back to that skiing analogy, if we tried to ski a slope like this, what would happen? All right, we would crash. We would probably hurt ourselves. It would be impossible to actually ski a slope like that. That would just be falling. It wouldn't actually be skiing. So it's impossible. You can't do it. So therefore, it's no slope. Whereas with the horizontal line, you could ski it. You just wouldn't go anywhere. So it would have a 0 slope. So those are two different things. Having a slope of 0 is different than having no slope at all. And let's look at number 11. Hopefully we can just look at that one and say the answer real quick. No work whatsoever needed on that one. My slope is going to be 0. Remember, any horizontal line is just going to have a slope of 0. If you wanted to just do your slope table, or slope box, you could. It would be the same exact thing as what happened in that, where we would get our y value to be 0, and then 0 divided by anything would be 0 as well. So my slope is 0. No work needed for that one. I can just fill out the answer. And last two problems like this. Go ahead and see if you can find the slope of those two lines. And pause the video in a couple seconds, I will show the answer. All right, so here are the answers. Go ahead and pause your video. Take a look at my work. Once again, you see the points here, 3, 4, and 4, 3. Throw them in the box, get -1 over +1 as the change. And then that would just be a -1. And if we look at problem 13, we've got 0, 4, and 3, -3. Throw them in our box, get a decrease of 7 for the y, get an increase of 3 for the x, so then my slope is -7 over 3, which I can just write as a -7/3. If you have any questions, make sure you get those asked, but go ahead and take a look at that work and pause the video.